This is Professor Darrell Seitz, Trigonometry, Unit Circle Tool. Each point shown on the below unit circle represents the terminal side of an angle in standard position having the indicated radian measure. The 6 trigonometric functions are defined for any angle in a unit circle context in terms of the x and y coordinates of its terminal side intersecting point. It's important that we analyze this unit circle tool diagram. It has a lot of information and it will help you navigate the waters of trigonometry. It will be very useful in solving problems. So we have, first of all, a unit circle with radius 1. Everything's in standard position. Here's the origin 0, 0, the x-axis, the y-axis, the point 1, 0, x of 1, y of 0, and 90 degrees up here on the y-axis, 0, 1, over here on the x-axis, negative 1, 0, and down here, 0, negative 1. And then there's other points. First, the acute angles, less than 90 degrees. We have a pi over 6, a pi over 4, and a pi over 3. That's radians. And in degrees, there are 30, 45, and 60. And here are the actual coordinates of these points. And it's important to understand that on a unit circle like this, the coordinates, the x and the y coordinates, are the cosine of theta and the sine of theta. So for example here, for pi over 6, the cosine is the square root of 3 over 2, and the sine is 1/2. Very quick way to see relationships. As we move around the circle, we see, well, a 0-degree angle. The point 1, 0, cosine of 0 is 1, sine of 0 is 0. Pi over 2, 90 degrees, cosine is 0, that's the x-coordinate, and the sine is 1. We go one time around this unit circle, and the angles are increasing. They go 90, 180, 270, all the way back to 360, or 2 pi, which is one complete rotation, one revolution, and you're back where you started. And you could keep going for larger angles, or you could do in a negative direction, but the concepts are the same. And notice the color coding. Here we have pi over 3 and 2 pi over 3, and 4 pi over 3, 5 pi over 3, and for each of them, look at the cosine and sine. They're all variants of 1/2 and the square root of 3 over 2. The only thing different is the positive or negative sign associated with them. We'll learn in a later video that angles like this, like these 3 red ones here, their reference angle is this acute angle, pi over 3, and they have the same cosine and sine, except possibly the positive or negative sign is different, and you can tell that by what quadrant the angle's in. Because remember, the x-coordinate is the cosine and the y-coordinate is the sine, and we know whether x is negative or positive and whether y is negative or positive in each of the quadrants going around the circle. This is a very powerful tool, and you should refer to it often to find answers to these common angles that you will have to deal with very quickly.